good for everybody, and it is now recorded. Okay, good. So that's going to be like one potential isomer, right? So that's going to be our pathway number, whatever, like 1, right? So when we remove H's from carbon number 1 and 2, 3, and 4, right? So now there is going to be adjacent, right? So adjacent houses, I don't know if you think about some kind of like triplex house, right? So there could be house in the middle, and then there is house on the left and house on the right. So, and then house on the left and right are adjacent houses to the house in the middle in the triplex building, right? So if you think about that as an example, or I don't know, if you have, let's say, like three potatoes, right? So you have potato in the middle and potato on the left and potato on the right. So then left and right potatoes, the kind of like left and right wing potatoes, so to speak, will be adjacent to potato in the middle. So that's like another like way to think about that. So anyway, so we removed H and OH from carbons 1 and 2. That's what we make, right? So now the second pathway can also take place, right? Because you have, again, this is the central carbon like with OH, let's call it this way, right? So whoever has the like, whoever is like alcoholic will be central. And now this is kind of adjacent and adjacent, right? Carbon and carbon. So now we can also remove the H and OH from here, from carbons 2 and 3. So this is 2 right here. And now that's what we are going to obtain. Okay, well, we'll redraw like so. Then free electrons will be liberated. And now you are going to like make the double bond here, right? So that's it. So that's going to be a different compound. So because double bond here between carbons like 1 and 2, here it's between carbons 2 and 3. So it's a different compound, right? Different placement of the building block of the double bond. So these are isomers, right? Couple alkenes. So here you make 2 products, right? So conditions are the same. So, and we pretty much kind of like use that thinking, right? So central alcoholic carbon, find it. So then adjacent carbons yeah, so and then remove the H's from the adjacent carbons, right? And then make your stuff. So now let's see what we have. Okay, so now we have activity number 1. So it's going to be up to 2 people potentially, right? So we have 1 candidate very swiftly. So, but as usual, I'm saying just I'm trying to give options for everybody. So if anybody new wants to give a try, so for activity 1, they are welcome to do that. So that's activity number 1. So show the major and minor products in the dehydration, demonstrate through chemical reactions of 4-methyl-3-pentanol and 2-methyl-2-pentanol. So yesterday I just Googled that simply. So, and I was able to like I was given the structures. So even though you are averse towards nomenclature, you can still find a structure, right, of the compound. That's not like a major roadblock here. So these days it's like pretty easy. So, but honestly, so we can use our current knowledge and then also do that. So we have candidates. All right. So let's see. Yeah, you can go. So like that's activity number 1A. So that's what we'll try to do. All right. So let's get to that. Yeah, so there will be more. So there will be up to like 6 more activities. All right. So that's your sheet. And yeah, go ahead, do that. All right. Let's see what we will get. So that's a little bit of nomenclature there, right? So show your compound, right? So we have pentanol as far as I remember. Okay, so that's okay, and we have the metal. All right, so yeah, that's your stuff. Good. So H2SO4 conditions, good job. And then you have the 180s. So like remember 180s. So that's what kind of like we also need to catch. It's a higher temperature, then it will be somewhere else, right? So let's see what we are going to get. So that's one option. Okay, great. Plus H2, right? So what's going to be another potential isomer that we are going to make, right? Because there are 2 adjacent carbons, as we can see. All right. So, and where is the double bond? All right, great. So that's where the double bond will be placed, right? So, and now use a different color and then circle the carbon containing groups that are attached to the carbon-carbon double bond, right? So,
Like circle the.
yeah, that's right. You can circle them and then it will give people the like numbers, right? So we have, yeah, that's CH, no, attached to the carbon-carbon double bond, right? So for example, this one is attached. That's methyl attached to the, yeah, that's right. So you need to circle that. Okay, great. So then another one. Where is another one? No, that's a carbon, that's a sp2 carbon. That's from alkene, right? So more lower. Yeah, that one, that's attached, right? So, and now another one, there is a CH2 attached to your carbon with the double bond. A little bit lower, no, to the left. Yeah, this one. So that's 3 carbons attached to the carbon-carbon double bond. Good job. So you now do that for the other product, right? No, that's too far, I would say. So you have the carbon here, so that one. Great. So that's group number 1. And then where is another one, which is attached to the like more to the left. Okay, and a little bit more to the left. Yeah, that one. So that is attached directly. Okay, great. So now you count the groups, right? So which one is the major, which one is minor? So let's help your peers. So which one is major, which one is minor? So let's say top and bottom. So which one is the major? Top or bottom?
This one.
Yeah, that's right. That's the major. So because you have more groups attached to that, great. So that's the major. You have 3 dots basically, right? 3 blue dots. And in case of the minor, you have, so this is kind of like, don't count that. So that's going to be the one, right? Perfect, right? So you have only 2 blue carbons attached directly to the carbon-carbon double bond. That's it. Okay, well done. So good job. So now, thank you. And anybody wants to give a try to the second? We have activity B. All right. So let's see. Yeah, you can go. So yeah. So activity B. Let's see what it brings to us. So that's gonna be more sheets here. All right. 2-methyl, 2-pentanol. Right. So on the second carbon, there are 2 thingies. So colors, your choice, and yeah, let's see what happens. 2-methyl, 2-pentanol. Quite exciting. All right, so that's looking good. Very with skeletal structure drawing. So you see, it kind of like gives you some speed. So that's why it's important. But you're welcome to show like H's explicitly for your, as I say, like counting, right, of what's happening. So yeah, that's just a tip. Or maybe you don't need that. So maybe you'll just like, figure out everything without like additional H's drawings. So here, let's think. So like we need to make sure that we don't lose the carbons, right? So the carbon groups look good. So you miss exactly 1 carbon, right, in both structures so far. So it's 2-methyl, right? Used to be 2-methyl.
Yeah, it is.
So yeah, where is the methyl at? So it just needs to
Down
stay.
here.
Yeah, show it up. Yeah,
Up.
to make it kind of like more trigonal planar. Perfect. So yeah, that's the ones. Okay, and then which one is major, which is minor? So let's just
This top one.
top one is the major. So yeah, great. Again, because it has more carbons attached to the carbon-carbon double bond. So here maybe I can use the like red color, for example. So what is attached is kind of like 1 bond away from each carbon-carbon in the double bond, right? So that is attached to the carbon, that is attached, and this is attached, right? So this is attached, that is attached. So the carbons which are kind of concerned, right, are going to be the green ones. Green carbons make the double bond. And now we count the things which are attached to them, right? So we don't count the green carbons. It doesn't make sense, right? It's 2 carbons, 2 carbons. So like it's a math point, right? It's not different, right? So that's the entire thing to make an alkene, and that's it, right? So and then what's gonna be like making a difference is the secondary things, right? Which are attached to the green carbons. This is attached, you see one bond away, one bond away, one bond away. Same thing here, one bond distance, one bond distance. So here on this carbon, you don't have any like carbons, right? It's like two H's and that's it. So, okay, well done with activities number 1. So, yeah, now let's move on. So we are going to get to the new reaction type, I would say. So that's going to be the condensation of alcohols, as they call it, right? So, and then here we are going to make a new function group, which is going to be known as ether. So this is just going to be like a general reaction, right? So R, again, stands for some kind of like random, we might call it, a functional or group. Typically R, for like now, it's going to be some sort of like alkyl, right? So sometimes it could be, for example, not an alkyl, it could be phenyl. So, but typically it is something like relatively simple, right? Unless specified otherwise. So, yeah, that's going to be the general like reaction scheme, right? So you have 2 molecules of alcohol for ether formation. So then you will subject it to conditions. So pay attention here. It's not 180 anymore, it's 140, right? It's a lower temperature, which is kind of like an important piece in the conditions because it will give you the ether target product, right? So if you are concerned with the ether formation, and the water will be released, right? So now let's take a look at some like specific examples, right? So here we have it, right? So now our R groups will become nothing more than ethyl and another ethyl, right? So both attached to the like OH makes ethanol. So now they will be able to react and make the ether as a result, right? So if you look at this slide, so you will see the water will be kind of in green, H2O. That's what will be released, right, as an HOH. So, and the leftover part, you'll just need to connect them, right? So, for example, here, if you imagine, so those like red electrons, you will technically like have this like free electron on the oxygen, right? So in addition to the lone pairs. So, and then also we'll have the free electron on the carbon here, right? So that's going to be the one which will participate in the single bond formation, right? So, and then this bond will be between carbon and oxygen, right? So maybe we don't show it here, so that's okay. But for our case, we can demonstrate it, right? So that's going to be the single bond. So it's kind of implied based on your knowledge of the oxygen and carbon bonding, right? So if you know what you're doing, then you will be able to say that there's going to be like a single bond between carbon and oxygen, right? So that's why the previous knowledge kind of is important, right? So now let's take a look at some like more examples, right? So here's like a relatively complicated alcohol, and then we'll be able to get into activity number 2. So if you looked at what the phenyl group is, then you'll be like in a good shape here, hopefully. So, but now let's take a look at this like alcohol here, right? So that's the question, right? So first of all, I'm gonna do what? So I'm gonna show the bonds, right? Sometimes it helps, right? So yes, you can be fast, kind of like by drawing those skeletal drawings. So that's okay. Good for you. So, but then sometimes, so for like our tracking purposes, it's possible, it's good to show the bonds, right? Which are going to be participating in the chemical reaction. So now that's the bond, right? So with between O and H, that's what will be kind of like broken, right, to make the new product. So here we go. We need to have, for the condensation purposes, so we need to have 2 alcohols, right? Sometimes they can be different, right? So that's okay as well. So, but for now, let's imagine that this is going to be kind of like the same alcohol. And then in this case, you are going to just work with, so case A, right? So we're just kind of like modifying the slide a little bit. So that's going to be our alcohol. Let's say this one reacts with itself, right? So the same molecule. So here, as we know from the like previous knowledge, we are going to liberate the molecule of water as a side product. Maybe it will be helpful, right? So, but the bigger parts will be connected to make the bigger organic molecule at the end of the day. So you're going to basically, like for now, imagine that you're going to break this OH bond. but also which will give you H, right, for the side product of water. So now the another bond that will be broken will be this one, right? It's going to be between CH2. So this guy is CH2, and this is just oxygen, right? So this bond will be broken as well. So now you can maybe put them in circles, right? Some of you do like circles of different colors, right? So, well, that's great. So now here is your chance to colorize them. So now it becomes like H2O, right? So yeah, so that's going to be your side product, H2O. But again, it will be helpful to like figure out what parts will be actually left over to make the new bond, right? So, and then what will be left over is going to be what is not in the circles, right? And you have this kind of like connection between this electron from the oxygen. So then you can like make some kind of dotted line to this electron on the carbon, right? And then let's just connect them, see what happens, right? So we'll have to redraw some things, oxygen here, right? So then this is going to be lost, right? So now you have CH2, and then like isopropyl, bless you, right? So we have here CH2, and CH with, so that's it. So I just flipped this like structure 180 degrees, and then that's what I got, right? So you have the red electron from your oxygen, right? So, and then you have this kind of like red electron from the CH2 carbon. So together they will make a bond. And now here you go. So that's going to be your compound, right? So this can be just a straight line here. So, and yeah. So actually, so I need to make sure that I have like CH2 and CH2, right? So we have one CH2, another one. And then yeah, here actually I made a mistake. So yeah, that's so bad. All right, so we have the single bond here. So now we are proper. So basically, if you want to redraw that, it will be like this. So we have here oxygen. So then CH2, and finally CH with a couple metals, right? So everything is taken care of. So these are your CH2 groups. That's the ones. So you have two from each molecule, and now, yeah, you are in a good shape. So yeah, so this is like not good. All right, so that's your like final compound that you are going to make, right? So sometimes, so just like here on the slide, we have also two different alcohols, which will kind of like resemble activity number 2. So now let's see what we are going to produce as a result of like two different alcohols reacting with one another. So that's not a problem either. So yeah, because we know what needs to be done, right? So we need to remove the water molecule anyway in this situation. So here we go. So that's going to be our alcohol number 1. So looking like this. And now the alcohol number 2 will be much simpler. It is just CH3OH, right? So then we are going to eliminate the water molecule as a result. So OH and H will be gone. So and now we are going to connect basically. So here's going to be a little bit easier, surprisingly enough. Oxygen will be connected to this carbon, right, to the methyl group. So as a result, so we are going to get our target compound, right? So we have oxygen and CH3 on it, right? So that's it. So again, the conditions are still the same. H2SO4 at 140 this time around degrees Celsius. Okay, so these are kind of like two possibilities, right? You have either two identical alcohol molecules or you have two different alcohol molecules reacting with one another. So now let's get to the second activity, right? So make it a little bit more challenging. So you have a primary alcohol with a phenyl group, right? So yeah, any primary alcohol with a phenyl group. So let's see what happens, right? So any primary alcohol with a phenyl group. So primary alcohol contains phenyl group. So, and then you need to show the ether formation from this, right? So that's what we are gonna be after right now. So let's see. So we have some candidates. wanting to do that. So, but if you are new, so, and again, so this was posted before. So, but anyway, so you might as well give it a try, right? So, ether formation. So easy, 3 points relatively at the very least. Okay, so let's see. So 3 points. So it's gonna be like a nice difference, right? On the exam, maybe you will not have to like chase extra points, right? And then argue that, oh yeah, that went this way, not that way. So ether formation, right? So we have a primary alcohol with the phenyl group, right? So that's what we need to have. It needs to be primary alcohol. All right, and the phenyl group must be there as well. All right, so yeah, go ahead. So that's activity 2A. So we still have 2B pending, right? So think about the aromatic alcohol and alkyl alcohol. So in the meantime, but now let's see what Bryant can show us for activity 2A. All right. So let's take a look. Okay, some sort of primary alcohol, right? I think with the phenyl group, that's what we wanted to make. So first of all, phenyl group, right? That's going to be already on half of the like process. So and okay, so that's the primary alcohol, right? So now we must not forget something for the to make the phenyl group phenyl, right? So great. So now it's proper. And you have the primary alcohol. So great, because the alcoholic carbon only is attached to one carbon, right? So that's primary alcohol. And now that's going to be ether formation. You need to have only 2 identical molecules of this alcohol, right, to make an ether. So now let's show the conditions, right? So yeah, good job showing 2 molecules like, separately, right? So water will have to be lost. And now the also show the like reaction arrow, right? And the conditions like above and below. So that's going to be kind of an important deal because some people will come after you if you don't show it, right? So, okay, now it's all proper. So, and now we're going to connect. That's going to be like a challenging part. The original things to make the product, right? Or the remainder, so to speak, of the original things to make the product. So we have CH2, CH2O. Okay, good. And now we need to have CH2, CH2. Okay, and the phenyl. Yeah, okay, you're on the right track. Good job. And that's the one. Okay, well, that looks great. So that's going to be your ether. Yeah, that's right. So you just need to kind of like remove one double bond. That one, that's like an overkill. Yeah, that's right. So there's no double bond. It's just a single bond. Okay, so we have an alternating double and single bond, right? So great. So that's well done. Okay, well, that's pretty swift. So yeah, so like we removed the water and then we connected the remainder of the organic molecules, right? So now activity 2B, right? So we have an aromatic alcohol and an alkyl alcohol. Alkyl alcohol is just the one with some sort of carbon chain. Aromatic means you need to have the phenyl group, right? So that's a couple conditions here. So if you're too scared of the phenyl group, so you might as well try just some sort of alkyl alcohol, alkyl containing alcohol. So I give some options here, right? So for the aromatic alcohol, so I can give you some option as well. So if you want to try that. So alkyl, it's just the alkyl substituent, right? So you can think about maybe like pentyl, for example, right? Or hexyl, whatever it's going to be, right? So that comes to your mind. So for the aromatic, so it could be as simple as phenyl, which you have seen in the past, right? So that's the one. That's your option here. So carbon OH, so phenyl as an example of the aromatic alcohol. And then you have the alkyl alcohol. So any alkyl chain you want. So alkyl alcohol, like OH here, right? And then maybe we'll have something like that, right? So that's it. All right, so we have one. Okay, so yeah, if you want, you can go ahead. All right, so let's see. Yeah, so we have the respondent already. All right, so let's give those a try. So now it's enforced, right? Now it is not like your choice, but yeah, if you made up something yourself, you can do that. So, but you can also give that a try. So yeah. So that is 5 carbons there. 1, 2, 3, 4, and not enough. Now it is 5. Okay, good. So yeah, well done. And then you have the water as a side product. And then show us the conditions as well to make it proper, right? Because we don't want to show the chemical reaction. So it's going to be the arrow there, right? From reactants to the products. That's your acid and 140 degrees Celsius. Great. So like some things can become like redundant, right? If you look at that. Okay, well, that is well done. So that's your ether formation right there. Right, so now let's take a look at the further, I would say, reactions, right? So that could be possible. So again, just to kind of like reiterate, so take your H, right? And then OH. So no matter how you look at this, you will lose water anyway. And then the remaining parts will inevitably give you this kind of like connection, right? It's going to be some kind of like stuff attached to oxygen, and then more of the substituents, right? So if you try to think about that, this will lose OH, this will lose H, the result will be the same, right? So yeah, it's just going to be like, doesn't matter. So yeah, anyway, so now let's see what else we have. So I think we maxed out on ethers. And now we are going to take a look at the like further processes, right? Such as the oxidation, right? So maybe let's ask the question to the Google Classroom now. So let's see what we get here. So that's going to be reliant on your knowledge of the previous general chemistry, right? So what is oxidation? What is oxidation? And yeah, let's just like think about it. So that's the question now. So what do we need to do to oxidize something, right? So that is now going to be the question. So what is oxidation? Maybe like from your previous knowledge, or if you look at this slide, maybe you will also have some ideas if you just compare the structures, right? So because you'll need to like here H's are shown explicitly, so that gives you like some information, right, about this question, and then what like you need to think about. Okay, so but what about oxidation, right? So what happens, especially in organic chemistry? So that's kind of going to be the slide that will help us, right? So here you need to pay attention to the numbers of hydrogen atoms in your molecules, right? So let's see. Okay, well, we have like very organic chemistry definitions of oxidation, so that is great. So what is oxidation, right? So especially, yeah, I could have elaborated so by asking from the organic chemistry perspective, right? So because now it's not general chemistry, but there is some kind of like elements of general chemistry that will be carried over to here. So let's take a look at this. Okay, so oxidation. So like some people, a lot of people say actually good job here. So it is adding oxygen and removing hydrogen. So that's actually like perfect, right? So from the organic chemistry perspective, so what we want to achieve when we oxidize is in this case, so in case of like our alcohols, we are going to eliminate some hydrogens from the molecule, right? And then we are going to oxidize it. So that's going to be the organic chemistry perspective. In other cases, you might as well add or increase the number of oxygens. We'll see at this, we'll look at this a little bit later. So it's going to be the second stage, right? When you oxidize this compound, aldehyde, and you just make more oxygens as a result. So you are going to kind of like promote oxidation, right? So because you increase the number of oxygens. So these are kind of like two ways to look at oxidation, right? So reduction will be the opposite by extension, right? So that's when you increase the number of H's. If you go backwards from aldehyde, so add H's, you are going to make alcohol more H's, right? So if you reduce the acid somehow, then you can make less oxygens in the resultant compound. You are going to also like promote reduction this way. So these are kind of like things about the oxidation and reduction. So now let's maybe draw a little bit in detail, right? So see exactly what happens. So these are your functional groups to review, right? Aldehyde, alcohol, carboxylic acid. So again, so like we see them like just like from day one or something like that. So they happen to be here once again. So now let's take a look at some schemes, right? Maybe this one is a little bit busy, right? So, but it's okay. So now let's take a look at some like things that will take place, right? So if you want to show the oxidation, let's maybe kind of like get into some random alcohol with a skeletal structure, right? So here you have the expanded structure, but since many people have been using skeletal structures, good job with that, by the way. So we might as well just do that too here, right? So let's take a look at some kind of like alcohol, which looks like that. So maybe we'll have the, let's say, oxygen and H, right? So if I want to show the oxidation, right, and what happens, so in this case, it's going to be a good idea to show the bonds, right? So what's going to happen for the alcohol is the following, right? So again, you need to like figure out your like atoms which will be affected. That's the first thing, right? So now here you have it, right? So that's what you are going to oxidize. So in this case, we're going to remove the hydrogen, right? So from the carbon, which is alcoholic carbon, right? Because it contains the OH group. So, and then we're also going to remove the hydrogen from the OH group. So just like according to this scheme, so same thing, right? So here I just have not a random group, but 1, 2, 3, like three carbon chain attached to the like COH piece, right? Or like CH2OH rather. So now let's see what happens as a result. So we have, let's say, mild oxidation, right? So we have the mild oxidation. So, and then as a result, we are going to get the aldehyde, right? So that's like as far as the words go. So mild oxidizing agent gives you aldehyde from the like oxidation of the alcohol. So now let's see what happens, right? So I just need to make sure that I don't lose carbons, right? Because some people have been losing them, but then they kind of like were regaining them. That's good. So we have 1, 2, 3, 4, 4 carbons. So let's just show them this way, 1, 2, 3, 4, right? So, and then for our purposes, I'm going just to show this like carbon explicitly, right? So that's going to be this carbon here. So that's what I'm showing explicitly as carbon, like C, right? 1, 2, 3, 4, 1, 2, 3, 4, right? Still 4 carbons. So now let's see, we are going to remove this H and remove that H, right? So now oxygen will stay, and so that's what we are going to have, right? So now some things can be adjusted, right? So now let's think about it. So in case of oxidation, what is missing, right? So now that's going to be the question to you all. What is missing and how to fix it, right? So what is missing? All right, so that's the question. So can I just show it like that, right? So is it going to be like a good answer or not? So, or maybe I need to have something here. So what is missing? So pay attention to this carbon, right? Because technically it is a CH2 originally. So, but now I removed only one H and one H from OH, right? One H from the carbon, one hydrogen from the OH are gone, right? So you don't have to show them. So they're just somewhere in the complex mixture of products, right? So, but we need to make sure that we do show the correctly the organic product, right? So that's what is important sometimes. Okay, and it's supposed to be an aldehyde. So you can see what's supposed to happen ideally, like on the slide, but what's on paper, right? And how do we correct it? So let's take a look. And then here we go. All right. So some people say lone pair. Okay, good job. So you can definitely have lone pair. So the double bond is missing, right? So double bond, lone pairs. So, but what about carbonyl is missing. Okay, good. So some people define it, right? So they say the double bond, the carbonyl needs to be present, right? And now, so double bond. Okay, great. So that is going to be the double bond, right? And then also here, I must make sure that this carbon has the H, right? You used to have CH2, now you have CH. So just don't forget the hydrogen here. Now you're in good shape. So that's going to be your aldehyde. So if you want to show it this way, you can do that. So if you kind of draw the carbon like explicitly, then typically it's going to be required to show the hydrogen, right? So in other words, you can show this structure like that. So 1, 2, 3, 4, and that's going to be the oxygen. So that's fine as well. So that's going to be the pure skeletal structure, except you are showing the oxygen because oxygen is not implied. It has to be shown. It is your like hetero atom and such, right? So that'll be also good. So 1, 2, 3, 4, and then the educated person will understand. Okay, well, here's the carbon, and it must have a like a hydrogen here, right? So at this like vertex or band, in other words. So then, yeah, that's good. So that's your choice, or this is your choice, right? So then now let's take a look at the like strong oxidizing agent. So we can also use maybe the same alcohol, right? So with 4 carbons, so because why not? So and then see what happens, right? Once this is oxidized. So that's 1, 2, 3, 4, and then OH. So 4 carbons total. And now we're going to have the strong oxidizing agent, right? So here again, so just kind of like see the carbons which will be involved. So that's going to be a red carbon with an OH group. So here it's maybe kind of a little bit easier, right? Actually. So what you can think about is that essentially this group can stay, right? So this will be present in the final carboxylic acid molecule. So, but now, so you are going to have here, so if again, you know what the atoms are kind of like hidden in the skeletal structure, then you'll realize there are a couple of hydrogens, right, in there. So now the hydrogens will be removed, and then you are going to make your acids. So again, we can like show them like so. So then we say that we are going to remove a couple hydrogens, right? So now what's going to happen next? Let's take a look at that. So next we'll make the product, right? So again, we can show explicitly one of the carbons, especially the red one, which will obtain something, right? So that's going to be OH here. And now you are going to have technically 2 free electrons on this red carbon. That's the red carbon right there. So then you are going to increase the number of oxygens. Okay, that's great. So, and now that's it. So yeah, now the question is what is missing again, right? So that's going to be another question here. So, and then how should I correct it? So like what is missing? So let's ask that. And then what do we need to add, right? So lone pairs could be the case, right? But maybe something else needs to be added in this situation. So can I just leave it like that and then go away? Or maybe something has to be corrected, right? So attention to the paper, right? So that's like what we're looking at. That's what we're considering. Like what is missing in this situation? Like, is it like a proper way? Or I can just abandon that and give up, right? So who knows? It's up to you to decide now. So anyway, so what is missing now? All right, so great, good effort here. So people say double bond and lone pairs. All right, great. So that's like pretty straightforward. Yes, that's right. So your oxygen is divalent. It can make two bonds, right? So considering the hydrogen just kind of got two liberated electrons. So that's going to be it, right? So that's going to be your like carboxylic acid. So maybe lone pairs. So yes, you can show them and then you'll be in a good shape. All right, so now these are going to be like our two examples, right? So that will hopefully give us ways to work with other things, right? So now it's a special case about secondary alcohols, right? So like previously we were just looking at primary alcohols. So now let's take a look at the secondary alcohol. So because again, this will be happening later on in one of the activities of the day, right? So secondary alcohol. So like first of all, so just can go like step by step, right? What is the secondary alcohol? That's when we need to have, okay, an alcohol, right? And actually that's what we started the day with the secondary alcohol of isopropanol, right? So it used to be like that. So that's your isopropanol. CH3, CH, CH3 again. So, and now let's imagine that you are going to oxidize it. So we are going to show the hydrogens that will be removed. So H and H will be removed, right? So you are going to have free electrons, right? So which will be looking like that. And upon the oxidation, so here we have mild or strong, right? So it's like pretty good here. So you have some like liberty, so to speak. So mild or strong oxidizing agent. So let's redraw the structure. As a result, we are going to have something like that. So that single bond still stays, right? And now you have the green electrons, right? So, and here, so well, I'm not going to be asking this question, so it's pretty straightforward. So you just need to make the connection. And now you are going to make your ketone, right? So that's going to be the same as, so as this structure, right? So you have your methyl. So then you have carbon here, CH3. So then you have the double bond oxygen, and that's it, right? So you see, so there used to be H, CH, now it is just C by itself, right? So that's all you got here. So that's your ketone. So you have carbonyl surrounded by a couple more carbons, and then that's going to be the ketone functional group present in this molecule as a result of this oxidation. So now let's see if we can graduate towards activity number 3, right? So ketone from 1-hexene. So this one will require a little bit of thinking. So, but maybe you looked at this yesterday. Maybe you can give it a stab now. So, but we need to start with the 1-hexene and then make a ketone out of that. So maybe we can split those activities between like 4 people, right? So, but anyway, so 1-hexene. So activity number 3, honestly, this one will be a little bit of the review, right? So because now it is just kind of like separate reactions. But what will happen next is that eventually we'll be going to the chains of reactions, right? So then this will inevitably lead us to reviewing materials from the past. So now here we have 1-hexene. I can give some hints and like not just whatever, right? So 1-hexene is an alkene, right? And then alkenes can undergo hydration. So they can consume the water molecule, right? And make something out of themselves, right? So let's start thinking about that, right? So because this will lead us to the oxidation, so for sure. So that's like the purpose of this activity. So, but for now, a little bit of the review. So we have 1-hexene, and then we want to show the hydration. So we already have one candidate. So yeah, let's just go ahead and start with 3A, right? So that's going to be 1-hexene hydration. So that's the big hint right there. So colors and everything. So yeah. And yeah, that was already in the past, right? So, but might as well show up on the final exam. So we have 1-hexene, that's a nomenclature question. 1, 2, 3, 4, 5, 6. Good. So what does it do upon the hydration, right? So we here can apply the rule, right? By the way, right? So H will go to the carbon with more H's on the double bond. And we are going to form the, so it's going to be not the primary alcohol. So remember the rule, right? So you're almost there. So count the H's on the carbons with the double
Oh,
bond.
yeah.
Yeah. So H goes to more H's, OH will go to the other one. So that's it. So that's the secondary alcohol, right?
Can I do the?
So now we can do the next step, right? So, but let's show the bond between carbon and O as well, so people can see. So in your like next reaction step. Yeah, so now it's proper. So secondary alcohol, right? So again, 6 carbons. Good. So now we're doing something else with that. So, what's happening next? You are going to make a ketone out of that, right?
So I'm
you're
gonna do
going to-
maloxidation, right?
yeah, that's right.
Dehydrate.
Now it's oxidation. So again, so like ether is not a ketone, right? So they're kind of like looking like similar, but they're not the same. So mild oxidation agents. So you're oxidizing now the secondary alcohol, and then that's the ketone you're going to make. So make sure that your carbons are all in check. And yeah, okay, well, good job. So that's kind of like the first ever step-by-step synthesis that we performed. So yeah, a little bit rough at the beginning, but then we kind of like bounced back. Okay, good. So that is well done. So here we have it, right? So just to reiterate your like review purposes, right? So we have 1 H, here we have 2 H's on this carbon, right? So then consequently, so yeah, this is going to be like not the case. So you will have the H from the water coming to carbon number 1, right? And then OH will go to carbon number 2. Hence, this is going to be our like major product, right? So that will be formed according to Markovnikov's rule, right? So that's like M rule. So okay, well, this is well done. So now let's see if we can maybe tackle 3-phenyl 2-pentene. Okay, so ketone from 3-phenyl 2-pentene. So yeah, again, activity 3B is pending, right? So it's going to be a little bit bigger compound. So, but it is still up for grabs. So like we have one candidate. So let's think about that. So maybe somebody else would like to go. So again, I just want to give ways to new people to try that, right? So try to earn 3 points, and then no matter how like it goes, right, you will earn the points anyways. So yeah, I gave it to like everybody so far in the history of this action. All right, so right now, so let's just let activity 3B stew a little bit. So, but now let's take a look at some kind of cases when you don't have the reaction, right? So because it also can happen. So that's when you have the tertiary alcohol. So the reason here is that if you try to kind of oxidize it, right? So you would remove the H from the OH group, and as a result, what's going to happen is that you are going to form something like that. You'll have like R carbon, maybe another like group here, and then another one, and now you are going to like theoretically have that. So, but the problem is that you are going to have a pentavalent carbon, so this will not happen. Consequently, you are going to have no reaction if you have the tertiary alcohol, right, under consideration. So now, okay, well, let's get to activity 3B, right? So we are going to form a ketone from 3-phenyl 2-pentene. 3-phenyl 2-pentene. So it seems complicated, but in fact, it is just alkene with honestly one substituent, right? So which was shown to you by Brian already. So we can ask Brian, what's the phenyl, right? So maybe he'll be able to show you some drawings, right? So that's an option. You'll develop your communication and networking skills, right? So that's what you'll need to do in the future. Send people articles so that they can give you the job or something like that. So I literally read it the other day. So, and then you might as well like network with one another. So to develop the skill. So now let's take a look at activity 3. So we have at least one valiant person to to do that, right? So 3-phenyl 2-pentene, but maybe somebody new wants to give it a try. So 3-phenyl 1-pentene, right? So we are going to do something with that. So what's that? Okay, so we're going to make a ketone from 3-phenyl 1-pentene, right? So the sequence of chemical reactions again. So 3-phenyl 1-pentene. Yeah, let's take a look at that. So like 2-pentene, right? So it needs to contain 5 carbons in the main chain. So carbon number 2, that's where the double bond starts. Carbon number 3, that's where the phenyl group is attached, right? So that's how you can think about that. So if you just break it down into pieces, that's going to be like not so bad. So let's see. Anybody wants to give it a try, they are welcome. So again, if there are some kind of mistakes, we can correct them on the go. So all right, so yeah, let's go ahead and then do that. So 3-phenyl 1-pentene, big molecule for the end of the presentation today, but it's exciting, hopefully. Okay, 3-phenyl 2-pentene, and then it makes some sort of ketone. So that's what you'll need to show to your peers. All right, so colors here. So you just grab them and draw. All right. So let's take a look at this 3-phenyl 2-pentene. All right. So like we have the dots for the carbons. Good job. So we need to have 5 dots total, and we can connect them. And now it looks good, right? So then maybe number, right? That's going to be useful. You can
You
start
want me
from
to
any
number?
end, like left to right, for example, like 1, 2, 3, 4, 5. So, and now it will be like helpful to you, right? Primarily. All right. So 3-phenyl. So that's going to be your phenyl group. Great. On carbon number 3. Then the double bonds, right? Alternating double bonds are in there as well. Okay, great. So now, yeah, what is next? So we are going to do some reaction from the past, right? So what will it be? It will be the hydration of the alkene, right? So H2SO4 and like water will be added as well. So that will be like the one of the reactions. Okay, yeah, that's one way to show that. Good job. All right. And where is going to be the alcohol at? So 3-phenyl 1-pentene. Okay. So that is one possible isomer that you can form, right? So all right, so now here is the question, right? So yeah, that's okay.
Is that
That's one
okay?
way. Okay, so like you have where is more H's? Let's see, carbon 2 or 3. Which one has more
3.
H's?
Do you want me to show it?
Yeah, so the alcohol will go there, right? So in fact, so
Oh, the
OH.
alcohol will go here?
Yeah, that's
Oh.
right. So because you need to put it to the carbon. So H will go towards more H's, right? So and then carbon number 2 will have just the hydrogen, right? So it's going to be no OH anymore. So and yeah, so that's it. So but now the question is, can you form a ketone out of that, right? So like, what kind of alcohol is it going to be? So is it a secondary alcohol or is it tertiary?
Tertiary?
It's tertiary alcohol. So now will we have the reaction or no?
Uh,
So it was the previous slide from here. So that's about the tertiary alcohols.
No.
So now
there's
just
nothing.
no reaction, right? So just show it to the people, like, write it, no reaction, because you have the tertiary alcohol. So and then you can actually draw your other molecule, right? So which you draw previously and show the reaction with that. So yeah, let's say
Which one am I?
yeah, the previous one
This
where
one?
the OH was here. So yeah,
So I can draw that one and
yeah,
then the
yeah.
reaction.
Draw it back and then show the possible like the oxidation.
with that one, right?
Yeah, that's right. So, and from that, you can remove the H, couple H's essentially, and then you will make your product. So, yeah, that's gonna be an option as well, but it's minor, to be honest. So, yeah, that's the only problem that we'll have here. And
that right?
the more bonds on the cycle, right?
Oh,
So that's what you must not forget. And then, yeah, you're all done. Okay. Awesome. So, yeah. So if you worked to present today, please stop by to get your extra credit and we will be good. All right. So. And yes, you can just like type your name here, then I'll arrange everything.
oh, where do I,
What?
where do I take it?
So,
Oh, like at the bottom?
here, yeah. Right, so are you taking an exam or you want to? Oh, yeah. Oh, you're Lauren, right? Okay. Okay, well, I just like, remember. Okay, cool. So yeah, what's up?
We have 3 for each question, right?
Yeah. Yeah, you can just like show the 3, or something, so, yeah.
Oh, I just put it in as 9. Do you want me to do 3, 3?
Uh,
Because I was at 3 originally, and then I just did 2 today.
yeah, what are you, did you type anything?
Yeah, I just put in 9. I just added the 6 that I did today.
So this will go to, so you added to, okay, that will
exam
go
three,
to
I'm
exam
sorry.
3 already.
Yeah, so that should be
So
six,
then, okay,
sorry.
well, let's give you like 3,3, so that's just for my stats, and then this will be
Okay, so I'm
reverted
back to
to
3.
3. Okay, good, yeah, appreciate it. Okay. Yeah. Okay. So, okay, so yeah, it says, what's that? Non-aromatic hydrocarbon as one. So you can, I think you can just do that. So, start the drawing here. So, and then this will be your R's. So, but now contains like 4 carbons, right? So, but then, as you make an alcohol out of that, so this will become R once one of the H's is removed, right? So if you add like OH, go here. So this will, actually, yeah, that's fine. So, but now R contains only 3 carbons. So because we just chopped off that 4th carbon, right? So now this is 3CH2, that's your R, and then this is OH, and then becomes ROH. Yeah, I think they kind of give you some like liberties. So, but if there's an issue, you can just email and then people like do that, and that's fine. Yeah. Okay. So you're taking the exam, right?
Yeah.
Okay. So I just was sort of confused. So okay. So yeah. It's optional.
Yeah.
So yeah, if you can go there. So it's taught by TA from the chemistry department.
Okay.
Yeah. So yeah, that's just a different person, and yeah, it's a good idea.
Is it graded?
No, it's not graded.
Okay.
So she'll just kind of like go over some problems, like questions and such like that. So yeah, it's really like more like practice oriented, maybe like talk about some concepts, and yeah, that's just kind of another way to review the material essentially.
Sounds good.
Yeah. So, okay, no problem.
Yeah. So I just had 2 questions. One was about the homework website, because I still didn't get that figured out from the lady. She never sent me back a second email.
Oh, okay, I see.
It's just weird because you gave us access for the semester, right, with that code initially? Because did you put a code in the,
The same thing happened to me, actually.
Yeah.
I asked about that too.
because I no longer have access to the homeworks, and it's asking me to pay $120 for
Yeah,
a
okay.
month.
Yeah, so I'll talk to those people. So I think the kind of they had the like free trial access until March 11th.
Mhm.
So it was like a huge amount of time for some reason. So I don't know why. And but typically it is just either a 2-semester access for the fall and the spring, or it is 1 semester. So like it depends on like individual person situation. So yeah, the homeworks are only like 15 percent if you have done some of them. So like perhaps they kind of like this will be helpful. So yeah, it could be like as an option. So like, as long as you do well on the exams, that's what will help. So there was one person like I remember in the past, so like that literally did 0 homeworks, but took all the exams with a very minimal score and failed. So Jim can do it, for example. So if you do well on the exams, it's going to be like 85% of the weight of the grade, right? So, and then the homework, it's only 15. So 15%. So, but maybe those kind of like extra points here will carry over. Because I think it's in your case specifically, you will have extra points that
Yeah,
will be added and then they can offset the homeworks. So,
I mean,
yeah.
is there any way that I could like either get access to it without buying it, or would I have to buy it?
I'll need to like negotiate with like salespeople, so see what I can do, and then yeah, if I have those like options, then it's not gonna be like for like a lot, so but I'll see what I can do. So
Okay.
yeah,
Also, can I get my exam one? I never grabbed it.
exam one. Yeah, that's right. So it's all sorted now. So yeah, you can also like take it once I get to the office. Yeah, I'll be there in a few minutes. So then you are taking the exam at 9:30, right?
Yeah.
Okay, great. So yeah, like stop by sometime like at 9:30 or like a little bit after. So there's no rush. Honestly, I'll be there for the entire office hours. You can do it 9:45
Where's your office?
if you want. It's 117G. It's you go through the TA help office. And there is like another set of offices. And
Okay.
you'll find my office inside the like after you walk into 115, there is gonna be another door.
Okay.
Yeah. So yeah, I just need to kind of get my bearings together and then give the exam back meeting, and then you can come by like 9:45 or something, 9:40 if you